I hope you're all doing great. I'm Mr. Ish. Horizontal asymptotes, but specifically the determination for rational functions. In this video, I'm going to give you the surefire way of doing this determination in a very easy manner so you get it right 100% of the times. The main thing you want to do is focus on these type of questions in the following way. If you have a function and it's a rational function, you have some sort of polynomial in the numerator and some sort of polynomial in the denominator, just like how we have over here. For the numerator, you're looking at something called n. For the denominator, you're looking at something called m. What is n? What is m? The n represents the highest order degree of the exponent of the variable. Degree of, well, let's just write it as exponent of variable. And then, the m value will be exactly the same. The degree of exponent of variable in the denominator. What is the highest order degree of that exponent in the numerator? That's n. What is the highest order degree of exponent in the denominator? That's m. When you're looking at a question like this, you can easily see it in the numerator and the denominator. You're only going to have horizontal asymptotes in two cases. One, in the first case if n is less than m, and in the second case if n is equal to m. If ever n was larger than m, you're not going to have a horizontal asymptote. So whenever you're looking at these type of questions, look at only these two cases. That's where you're going to generate your horizontal asymptote. When I'm giving you this question over here, what's the highest order degree of the exponent in the numerator? You have 2x, but 2x really is to the power of 1. Here n is equal to 1. When you're looking over here, you technically have 5x squared plus 2x to the power of 0. You can look at it that way. But let me eliminate these extra writings so we don't get confused. What's m here? The highest order degree of exponent for the variable in the denominator, it's 2. Which case do we fall under? We fall right here under n is less than m. Whenever n is less than m, your horizontal asymptote is always y is equal to 0, which is your x-axis. That's just how it is. If you see a case where n is less than m, you don't have to do any computations. This right here is your horizontal asymptote. But for the sake of this video, I'll show you the computation and show you why this is the case every time you have this case. So allow me to show it to you so that you can have some level of certainty and assurity in this. I've told you here, if n is less than m, your horizontal asymptote is your x-axis, y equals 0, and I'll show you why. When you look at this numerator polynomial, you have 2x. When you look at this denominator polynomial, you have 5x squared plus 2. You take the numerator and you take the denominator and you divide it by the highest order degree of exponent variable that you see in the entire function. The highest order I'm seeing over here is an x squared. That's right there. I'll take the numerator and I'll divide it by x squared, and I'll take the denominator and I'll divide it by x squared, and then you simplify and see what happens. When you do 2x divided by x squared, you have here a 2 over x. When you do this and you separate it, you'll have a 5 plus 2 over x squared. Now what you have to do here, after you've done this little expression, you do like a limit here. Limit as x approaches infinity, and see what happens. As x approaches infinity, in each of these instances, what happens? You're really doing 2 divided by infinity divided by 5 plus 2 divided by infinity. Infinity squared infinity, it's all the same. Any number divided by a very large number eventually becomes 0, and you end up seeing 0 over 5, which is 0. And that right there is exactly why you're having this 100% of the times. When n is less than m, you don't have to do this computation. Just remember, the horizontal asymptote is your x-axis. For this specific question right here, your x-axis would have been your horizontal asymptote. And that shows that this question has been completed for this case. Let's look at the second question and the last question, because this will look at case number 2. When you're looking here at the n represents the highest order degree of the exponent for the variable in the numerator polynomial, and that's a 2. M represents the highest order degree of the exponent for the variables involved in the denominator polynomial, and that again is 2. This is case number 2. When n is equal to m, you can't assume your horizontal asymptote is your y-axis, but you have to calculate. You have to do a specific calculation. What is this specific calculation? It is kind of like what I showed you in the previous question. You find the highest order degree of variable you're seeing, and it's x squared. You divide the numerator and the denominator by that and see what happens. You're doing 2x squared over x squared. That's the numerator divided by that. Then you do the denominator by the same and see how everything plays out. When you do all of this, you're getting a 2. when you do this and you separate it along its separate fractions over this minus, you're getting a 3x squared over x squared minus 2 over x squared. When you simplify all of this, you're really seeing 2 over 3 minus 2 over x squared, because these cancel out. You still again do that same limit assumption, limit as x approaches infinity. As x approaches infinity, you're looking at 2 over infinity, which is a very small number. It'll be something like 0.0000 all the way, as many zeros, and then finally a 1, or whatever that number may be. It'll be some number here, but it'll be very close to, if not 0, which is why these type of instances always zero out. What are you left with here? You're left here with a 2 over 3, and that right there will be a horizontal asymptote. HA horizontal asymptote is 2 over 3. And this is a specific calculation you'll do. You'll always do this type of procedure, and you'll always apply this type of limit. If you were to graph it, just very quickly, I'm not graphing the function, I'm just graphing the horizontal asymptote. Horizontal asymptote 2 over 3 would be y equals 2 over 3. You know it's a value less than 1. If this right here is 0, 1, y equals 2 over 3 would be right here. Here's your horizontal asymptote. Your function will do something along this horizontal asymptote, and that right there is how you'll do it. Remember your two cases for horizontal asymptote, and this is my abbreviation for horizontal asymptote, HA. Case 1, n is always less than m. You have y equals 0. Your x-axis is your horizontal asymptote. N is equal to m. Case number 2, you have to do the specific calculation and arrive at your specific horizontal asymptote. These are the two cases which involve horizontal asymptotes. And with that, let's say goodbye for you in terms of this video. Thank you for watching. Have a good day.